So there's a new unit of temperature here that some of you may not have heard of before. It's called the Kelvin, and it's basically named, or it's basically there because we need a lot of, we need a higher temperature unit scale when we're doing some things in physics that have greater temperatures. But just the conversion, it's on the course. How do you convert from Celsius to Kelvin? Well, to convert from Celsius to Kelvin, you add 213.7 or 0.15, so add 273.15 and that'll give you the temperature in Kelvin. So you do that for all of them and that'll give you, so 0 degrees is 273.15 Kelvin, 20 degrees is 293.15 Kelvin, minus 100 would be 113.15 Kelvin, and 100 would be 373.15 Kelvin. If you have the temperature in Kelvin and you want to convert it to Celsius, then you subtract 273.15 and that will give you the temperature here. So just do that for all of them. So just get the answers here. So minus 173.15 Celsius. Do the same for all of them. So 273 will be minus 0.15. So to convert from Kelvin to Celsius. And then 373 will be 99.85 Kelvin. And 500 will be 226.85 Kelvin. Now the question on page 14.2, simple enough little question. If you read the previous sections here, but in particular the section at the top of that page, but if we just look at the question, so you're told that the length of the mercury column in a capillary tube is 3.2 centimeters when the tube is placed in melting ice. Now melting ice implies that that is at 0 degrees. In the steam above, so steam then, well, how does water turn to steam when it boils? So it turns to steam when it boils. What temperature does water boil at? It boils at 100 degrees. So if you look back in that question again now, so you have 2 points here. We're told that, so here's the length of the mercury in the column. I've done it in this scale here. It's measured in centimeters. And this axis here is the temperature in degrees. So the length of mercury in a capillary tube is 3.2 centimeters. So there's 3.2 centimeters roughly. When it's placed in melting ice, so it'll be, so basically if you want to look at it, I have two coordinates. I have 3.020, this being the length and this being the temperature. And I have another one then, when it's placed in melting ice, it is 22.3. So my second is 22.3 and 100 because it's in steam, so therefore it's melting. So just join those 2 points. There's the first point and the second point. So what, 22.3, it's roughly here, and 100, so somewhere about there. Now I join these 2 points and this is my calibration curve. So I can work out the temperature of anything now. So for example, if the length of mercury in the column was 20 degrees or 20 centimeters, it would be approximately what? Just nearly 90 degrees. Read it across like that. But the question says, if the length of the water in the column is 10 centimeters, then what is the temperature of the water? So basically the mercury expands. Mercury expands when heated. All metals expand when heated. So that's a thermometric property. The more the mercury expands, the greater the heat. So move it across like that. So that's actually a little bit wonky maybe, sorry. So it should actually be, so just maybe straighter up and then maybe move it across. So it's about 35 degrees, about 35, 36 degrees. So when the length of mercury in the column is 10 centimeters, it's 36 degrees. Other thermometric properties might involve a small current flowing when there's a temperature differential between two ends of a metal rod. So just to explain, the thermometric property is the mercury. As it gets warmer, as the temperature around the mercury gets warmer, the mercury will expand, and the more it expands, the greater the heat. So if I know when the mercury, what length the mercury column is when it's frozen, and I know what length the mercury column is when it's melting or when it's evaporating or turning into steam, then that gives me a calibration curve. So then I can work out the temperature at any length.